Breast cancer is the cause of more than 40,000 fatalities per year, and that's just in the United States. There are many unsolved mysteries around cancer, but among them is a rather puzzling one, the question of an ethnic disparity. Yes, a tendency for young women of African descent to be more susceptible to aggressive treatment-refractory breast cancer than their European counterparts in the United States. What causes this? What are the underlying mechanisms? Together with my advisor, I started looking for the answers, and we had a hunch that we might find them in certain genes. Now, I want you all to imagine an air traffic map. It's complex, it's dynamic, but tightly regulated. And that's exactly what the complexity is like in thousands of processes that happen in our cells every single day. In our cells, a molecule known as P53 does the job of an air traffic controller. In the cancer world, it's referred to as a tumor suppressor. Now let's think for a moment. What if there are different types of P53? Will they be able to do the job with the same competency? Maybe not. Therefore, we hypothesize that a difference in competency between African versus European types of P53 contributes to this ethnic disparity in breast cancer. Now, what causes this difference in competency? Among 3 billion bases that make up our DNA, we found that a single base change, that's right, one change from G to C can create differently competent P53 types. With studies using mouse models, we were able to show that mice with the African type of P53 were more susceptible to early onset aggressive breast cancer. And at the molecular level, African type of P53 was like a sleep-deprived air traffic controller. It could not perform certain key functions with the required competency. Through my work, I was able to show for the first time that a single change on P53 gene contributes to this ethnic disparity in breast cancer. And the underlying mechanisms discovered will be vital in designing effective preventative strategies to save the lives of many of our loved ones. Thank you.